begin by talking about computer science, and in particular, a subtopic of computer science, which is software development. Most of you would know as app development. Okay, so we'll cover some important concepts there. And then once we understand how software works, and we define some key terms that you must understand, we can then talk about the different applications of software, the different types of applications you can build. And two of these applications, right, with software you can have many kinds of applications. Two of them, which I imagine you're interested in learning about, is machine learning, which is part of this thing we call data science, and blockchain, a word that is used a lot, but it seems that many people exactly understand what it is. And of course, like I promised, towards the end of the workshop, I will tell you where to go after this session, especially if you want to become a software developer, and any questions you may have with respect to the topics we covered today. Very good. And by the way, if you have questions, you can also put in the chat. I'll make sure to address them at the end. So, yes.
We also discussed like software as a service, IaaS.
I can answer those questions towards the end, but it's not in the slide. But I can answer those questions towards the end. Look at this slide over here. These are logos. Logos are very popular programming languages. We have Python here, Java, JavaScript, C++, C#, PHP, R, Go, Golang, TypeScript, Kotlin, Swift, Scala, and of course, there are many, many, many more. So we need to establish two things. Right? You need to know that all programming languages will fall into two categories. They are either general purpose programming languages or they are specific purpose programming languages. Meaning some programming languages are used for a variety of things, but certain programming languages are used for a certain thing. For example, down here we have R. How many of you are familiar with R? You know what R is for?
Mathematical.
Exactly. R is specifically used for statistical analysis. All the functions, now what are functions we talk about? All the functions, all the many libraries, many programming constructs are built into R. Without installing anything external, you can produce visualizations, you can do things like ANOVA, you can measure things like covariance, correlation. These are statistical terms. So this programming language is made specifically for R. What you cannot do with R is build mobile applications or desktop applications. Okay, it's specifically for statistics. Conversely, or on the other hand, we have programming languages. Actually, all programming languages besides R here are general purpose programming languages. But some of these they do cover a lot of platforms, but not all platforms. And when I say platform, I mean desktop, right? So we have let's say three platforms. We have the operating system, that's one layer, like Macintosh, Windows, Ubuntu, Android, iOS. These are at the operating system level. Some of these programming languages are meant for the operating system layer. For example, we have C++. I mean, C++ is the father, or is that programming language inspired many of these other programming languages. So it's very old. C++ is used for mainly for applications on the operating system level. What are applications at the operating system level? Zoom is one, Chrome is another one, Microsoft Word, Microsoft Excel, Photoshop, right? When you log into your Macintosh, into your MacBook, or when you log into your laptop on Windows, those applications that you access through the start menu, you know how they have that .exe extension or .dmg? Most of those applications, not all of them, most of them are built with C++. Now you have also programming languages like Java. Java was inspired by C++. Java tried to address some of the limitations of C++. For example, if you build an application in C++ for one operating system, if you want to build an application or you want to ship that application for another operating system in C++, you have to do it again, right? Because, for example, Windows is very different from Mac. The architecture is very different. So you have to rewrite the application twice. A third operating system, you have to build it a third time. So Java came in and said, look, we have a better solution. Write the program once, and we will allow you to deploy it everywhere. Python originally started out like that. Its goal was to solve a problem that C++ had. We then have programming languages like Rust and Golang and Kotlin and Scala. These are programming languages that came after C++ and Java. Again, these programming languages exist to address the problems of their predecessors. For example, the team at Google especially dislike C++. Okay, in fact, I think that's one of their motivations. We hate C++ so much that we are going to create a new program language. So they borrowed what they like about the language, borrowed what they like about another program language, and they produced this Golang. But for example, C# was built by Microsoft for their operating system, applications that would run on their computers. But now it has extended to something like building mobile applications. So there's something called Xamarin. You can take a note of that. It starts with X. If the same problem we have with operating systems like Mac and Windows and others, that same problem exists on the mobile platform, right? We have iOS, we have Android. So again, if you want to ship a product, if you build it for iOS and you want to, like that application Clubhouse. First, they shipped an iPhone. They recently now made it available to Android users. Why? Well, because they had to build it twice. But you have platforms like Xamarin, which is programmed in C#, this programming language, which allows you to write the program once and ship multiple times. So we will talk about, which one you should get into after we talk about this slide. These are some of the systems that are made possible because of software, because of programming languages. You have web applications like YouTube, Netflix, Amazon, Facebook, Instagram. You already know these. We have desktop applications. I just named a number of them. Mobile applications, right? You have Facebook, but the native application. You have, what else? You have WhatsApp, you have Signal, you have Telegram. I mean, these are companies whose flagship product lives on the mobile phone. And you don't need to tell me just how much value they have, right? Because but just building an application on this one platform, they're able to generate a great deal of value. IoT, does anyone know what IoT is? Internet of Things? Very good. So these are devices that are connected to the internet, but they exclude laptops and tablets and iPhones. So personal computers or personal computation devices are not considered IoT. IoT is like the Alexa or your smartwatch or your Bluetooth headphone. Nike has started making shoes that you can plug into a Bluetooth. So if they stream data to the cloud, that is also considered Internet of Things. Blockchain, of course, that's a big topic. We'll come to that in a moment. Media streaming. If you want to stream video content or image content, you need specialized programming techniques. If you notice, for example, when you are scrolling through your feed on Twitter or Instagram or Facebook, it seems you can keep scrolling indefinitely, but you never experience lag, not unless your internet connection is disabled. So how is that made possible? Well, again, there are certain techniques and there are special programming languages that make that possible. Data processing, this is something done in data science. We'll touch on this in a bit, and so is machine learning. And machine learning and data processing are two things that happen under the umbrella of data science. Okay. Scientific computing. Again, R is an example of that. there are programming languages are also used for statistics, mathematical modeling. So for example, if you want to know, I don't know, the distribution of populations, and you want to be able to visualize this, that is considered scientific computing. So if you heard of things like MATLAB or Wolfram Mathematica, that's an example. Embedded systems. Embedded systems are also electronic devices that run software to some extent. This TV is an embedded, could be considered an embedded system. You know, when you try to enter a parking space, those gate opens up, that's considered an embedded system. CCTV cameras can also be considered embedded systems. And then we have autonomous vehicles, right? Tesla, self-driving cars. Software also makes this possible. And of course, fintech. So if you think about the world of finance, buying and selling stocks, cryptocurrencies, right? So buying and selling stocks is done instantaneously. Much of this is now being automated. Buying and selling of stocks is done automatically by software. You program it and you let the algorithm run, and it's trading on the market. The faster you can do it, obviously, the faster you can buy appreciating equity or stocks or currencies, and the faster you can sell them before they depreciate. So this is just a small list of many, many things you can do with software. In other words, simply put, software runs our world. I mean, the software runs our world. There's nothing you can look at and say software has nothing to do with this. Everything has to, I mean, software has touched every aspect of our world. Everything from, you know, interplanetary travel, you know, sending rockets to Mars and Moon and different planets, all the way down to the subatomic particle. Everything is being touched by software. So the things you can do with software are limitless. Very good. So now let me tell you about the principles. Any programming language, any person who wants to get into programming, must be familiar with these very fundamental concepts. And also, let me say this before I go forward. When I show you that slide with those programming languages, that circle, that does not include HTML and CSS. HTML and CSS are not considered programming languages. They're called, well, HTML is a markup language, CSS is called a style sheet. Let me put it to you this way. All of those programming languages I showed you have something in common. These things we call programming constructs, these building blocks. HTML and CSS do not have that. So the learning approach is different. The way you would go about learning something like Java or C++ or JavaScript is not the same way you would learn HTML and CSS. Here's the starting point. For learning any programming language, any of those logos you've seen, all of those programming languages, this is the starting point. First, let's begin with two important terms, the word program and the word process. Anyone know what these things mean? What comes to your mind? What comes to your mind when you, hello, welcome. What comes to your mind when you hear the word program or process? Type them in the chat. When you hear the word program, do you think they're the same thing?
Well, a program is like a set of instructions.
Set of instructions, and what is a process?
The process is a temporal aspect to those instructions.
That's a good explanation. Well, let me tell you the difference by jumping into this slide. Let this slide visually demonstrate the difference. This is a very important place for us to start. Program, as you said, is a file where you've written your code. You've seen pictures like this, right? Someone is sitting in front of a laptop, they have a black screen, and they're typing some ostensibly foreign language. That file, it can have a .js extension, .java extension, .py extension for Python. These are programs. When we run these programs, when you run these scripts, when you tell the computer, hey computer, run this file, and the computer starts to process it, keyword process, it then becomes a process. Here's another slide that will explain this concept further. Every computer Every computer that you know of, laptops, smartphones, tablets, even smartwatches, even those embedded systems, autonomous vehicles, aircrafts, drones, these are all computers. But in particular, personal computers, all of them have these three main components. If you're someone who wants to get into computer science, you must understand how these three components work together, at least to some extent. The first one is the processing unit. The first is the processing component. You know the CPU? We have the Intel chip. We have the new Apple M1 chip. We have GPUs from, for example, NVIDIA. What's the other brand?
AMD.
AMD, right? So we have all of these different chip producers. But all computers have this processing unit. Then we have two types of storage units. One for permanent, one that stores things permanently, and one that is temporary. What's a permanent storage? SSD drives, optical drives, flash drives, external drives. Anything where when you shut down your laptop and you turn on your laptop again, the file is still there. Whatever that thing is that stores the value permanently, that's what we call permanent storage. And temporary storage, now this is where you need to focus on as a software developer. Temporary storage. Another name for temporary storage is random access memory. Let me talk to you about how the processing unit and the temporary storage unit are involved, work with each other. So I'm going to talk about this, but mainly temporary storage. Again, this applies to you no matter which programming language you choose to work with. Here on the left is an example or a sample. Imagine this is a file. For example, this is JavaScript, and in this file we have written a JavaScript code. Okay, do not worry if you do not know what this code is. Just so you know, this is a set of instructions. When you double click on this file, when you run this program, in other words, and you feed it to the CPU is going to take pieces of data from this file that you've written and put them into this thing we call temporary storage. So for example, you may have numbers in there, you may have dates, you may have names of people, addresses of people, prices, whatever. The CPU is going to start pulling stuff into this temporary storage. So for example, you know when you're looking at an Excel document, you're trying to, for example, look up someone's name in an Excel document, and you're scrolling up or down, or you're switching from one sheet to the next sheet. Where are you pulling this data from? You're pulling data from the temporary storage. And you notice how sometimes when you try to switch to a different application, but your computer freezes, and you have this preloader, do you know why that's happening? That's because the computer is struggling to take something from the permanent storage and feed it into temporary storage. Usually when you fill the temporary storage to the full, the computer is not able to find any empty space. So it makes you wait. It says, wait, let me either shut down an application and make my life easier, or let me sort it out with you, sort it for you. So the operating system usually shuts down another application to make room for another application. This piece of information is very important for the following, what I'm about to explain next. Yes, what's the question?
So every often, right, in the resource model, you say think of swap.
Yes, exactly. The question was, there is when you see the activity monitor or the task manager, if you're talking about Windows, there's something called the swap memory or the cached files. Yes, the computer sometimes has no other option but to take something from temporary storage and put it in permanent storage. So for example, if you're working with 5 applications and one of the applications, the backend, you haven't touched it for the past 1 hour, without telling you, it's going to put that application or the content of the application on permanent storage. And then when you try to switch back to that 5th application after 2 hours, that the computer says, oh no, now the user wants something in permanent storage, I have to, anyway. So this is something you need to know about. You need to understand that the program that you write will affect temporary storage. And this should create a motivating reason for you to want to create efficient algorithms. And what's an algorithm? We'll come to that in a second. Now, speaking of that temporary storage, you see here, I've listed here as a list. Everything is like arranged neatly, nicely, neatly. In reality, this temporary storage is used for all of the applications running on your computer. You have Excel sheet open, you can be listening to music on Spotify, you have Chrome open, I don't know, you're looking for a nice bag or something. You're joining in the Zoom meeting but not really paying attention to the person talking. So there's a lot going on in your computer. You have 10 applications running at the same time, 20 browsers open in the browser. All of these applications are using the same temporary storage, right? However, the computer never mixes. It never confuses the pieces of data. For example, it will never be the case where you switch from Excel document and you go to YouTube, and then inside the YouTube player, you see your Excel table. It doesn't happen. That is because of something we call data structures. It's in the name. It's an abstract structure that contains your data. And this is where you as a software developer must have proficiency. Let me say this another way. There are many programming languages, and there will be more programming languages. Every now and then there's a new library. There is jQuery, there is React, there is Vue.js, Angular, PyTorch, I don't know, TensorFlow. What's another library you may have heard of? Jupyter, Scikit-learn, all of these. These things will come and go. One day this library will be popular, the next day the other library will be popular. And for someone who's trying to become a software developer, the question is, all right, which one do I begin? What if I start learning this? 2 months from now, this technology is obsolete. And this has happened to me, by the way. I used to work at a library called Flash. I don't know how many of you know it. But that became obsolete, and I had to drop that, adopt something else. So how do you future-proof yourself? How do you make yourself someone who will have a long, successful career in the world of software development? This is one of those things, data structures. Data structures are at the core of computer science. And this is something that all programming languages implement. Again, all programming languages have to work with those 3 components we talked about, right? CPU, a processing unit, permanent storage, temporary storage. And temporary storage depends on this. How many temporary storage is built with these data structures? So here's how you want to begin. You want to take a note of this. When it comes to data structures, we have 2 categories. You have linear data structures. Don't worry about the rest of the branch. Just focus on these 2. Linear data structures, nonlinear data structures. Linear data structures, for example, are things like arrays. And these are structures that hold on to your data and sort them numerically in order. For example, when you are browsing Excel document, right, you have rows and you have columns. This is what we call a linear data structure. For example, in machine learning, you have something called deep learning, where you work with these things we call matrices. In the programming world, we call matrices arrays. So if you want to become competent in machine learning, if you want to get into something called deep learning, which is the most advanced form of machine learning, guess which data structure you have to be familiar with? This one. And they're not very difficult to work with. You know, in our coding bootcamp, we cover this in a day. So if you learn this fundamental, if you know what an array is, if you understand what it means for a data structure to be linear, it doesn't matter which programming language you work with. All of them implement this. If you understand an array in Python, you will know what an array is in Java, or in JavaScript, or in C++, or in C#, and so on and so on. Then, of course, we have the second category. This is what you want to learn after you've learned linear data structures. Non-linear data structures include trees and graphs. You may have heard of a binary tree. That's a type of non-linear data structure. Graphs, for example, are heavily used in social media applications. Remember I told you about scrolling very quickly through your Facebook feed, your Twitter feed, Instagram feed, LinkedIn, and it seems to be infinite? That's because this graph data structure is, you can mold it in any shape you want. You can make it as small as you want, you can make it as big as you want. You can send pieces of it at a time. So it lends itself to being very fast. They're very good for searching, They're very good for streaming data sending data back and forth. That is not true with linear data structures. So you want to focus on these two. Start learning about these. Make this your priority. No matter how much experience you have as a software developer, you must be proficient in these two. You know, there was a very popular software developer who applied to Google, and they had that person work on a binary tree, in particular, reversing a binary tree. He couldn't pass the test. He was very upset. He was very, very insulted. He made a very famous post on Twitter because he's a very well-known person. And he said, yeah, I applied to Google, couldn't reverse a binary tree, and they couldn't hire me. By the way, I recorded a workshop on reversing a binary tree. It's 1 hour long. So you definitely want to check that out. It's also a good way for you to be exposed to the second type of data structure. So if I can say this another way, do not worry about libraries, PyTorch, scikit-learn, I don't know, jQuery, this, that. Focus on the fundamentals. The fundamentals are how you will be sure you will future-proof yourself. Okay? If you know what a data structure is, doesn't matter if you know Python, but you do not know, I don't know, Golang. If you know one programming language, and if you know the fundamentals, it will be very easy for you to learn another programming language. Let's carry on. Now, the word algorithm. Let me ask you all, what do you think the word algorithm means? In no more than 3 words, describe this word. What do you think the word algorithm means? What comes to your mind? What is the definition of algorithm? So for those of you in the chat, I want you to type in your answer. What does the word algorithm mean to you? What does it look like? Does it have a color? Mathematical function, that's one guess. Anyone else?
Sequential set of instructions.
Bingo, set of instructions. Set of instructions. If you want to tell a computer to do something, whatever that may be, open a file, send a video, send a post, find someone's email address in that Excel document I told you about. Well, you need to instruct the computer to do it for you, right? You need to tell the computer, I want you to do this at step 1, do this at step 2, do this at step 3. At step 4, if the data is missing, do this instead. Or keep doing this particular step over and over again until certain condition has been satisfied. This is an algorithm. When you instruct the child to finish their breakfast, that's an algorithm. Eat your lunch, finish your food, and you will get a dessert. That's instructions. Now, of course, humans are much smarter than these devices we have in front of us. So when it comes to computers, we have to be more granular. Like we have to be very detailed with our instructions. Like you have to explain every little thing. But no matter which programming language you learn, no matter what type of algorithm, no matter how lengthy your algorithm is, all programming languages and all algorithms have building blocks. You know, if I were to send you an email, if I were to talk to you on the phone, I will have to form sentences with words. I have to put words together, follow some grammatical rule, and then you will understand what I'm trying to say to you, and vice versa. Similar. So in English or Arabic or any other language, those building blocks are words, right? In programming languages, we have these things we call programming constructs. If you want to instruct a computer to do something, it will involve some of these or all of these 6 building blocks. Now, I will not show you these programming constructs, but prioritize these. You must know exactly what all of these mean. And by the way, you want to follow them in this order. So when you go left, top left to bottom right. First, actually, I would swap these around. So begin with variables. Begin with variables. Then try to learn about data types. Then learn about functions, control statements, and objects and classes. So these should come after. These should come after, okay? So start with trying to learn variables like the top 3. You can learn these in a week. Doesn't matter which program language you choose. I'll tell you which ones you should choose, by the way, if you're not sure. But prioritize these top 3, and then make your way to the bottom 3. It just occurred to me that there's a very nice website where you can actually learn all of these programming constructs. But you cannot become a competent programmer. You cannot be a competent computer scientist or software developer, whatever title you want to give yourself. You cannot be competent unless you know exactly what all 6 of these things mean. Okay? And like I said, doesn't matter which program language you choose to learn now, because all programming languages have these programming constructs. If you start learning, you spend 2-3 months learning Python, but then you find a nice job or your dream job, but they choose a different program language, and you panic and think, oh no, I know Python, I have to. No, if you spend 3 months learning Python, in a small fraction of the time, you can learn the other language or the other program language. Again, because they all have the same programming constructs. Let's move on. Now, we said that, the software runs our world, all kinds of applications. But let's talk about 2 of them today: data science and blockchain. So, data science, what's data science, right? That's another word that's thrown around a lot. And it's somehow associated with machine learning. So let me make a clear distinction. Data science is a field, is a new field. It's something that has come about recently. We didn't have the word data science if you go back a decade ago. Data science is a field where, let's say it's like an intersection of 3 other fields. The first one is statistics and mathematics. In fact, if these are the pillars of data science, this is the most important one. I'll tell you why in a second. But statistics and mathematics is the first pillar of data science. The second pillar of data science is computer programming. I would say you can say computer science, but as a data scientist, you mostly have to be a good programmer. So for example, you don't need to know how computer networks work. Computer programming is sufficient. Those programming constructs I told you about, if you know those, you're practicing data scientist. The third one is domain knowledge. Let me come back to domain knowledge after I talk about the slide. Now, does anyone know what machine learning is? What is machine?
How you're making your program, giving it a right algorithm to work on, and giving it a variable so it can learn from the data. You train the data, and then your machine learns from it, and then you test it later on the rest of the data.
So if I can rephrase your answer, just so those in the Zoom can hear, the answer is that algorithms to which you can pass variables and data.
You train your machine along with the data, and then you test your results on the rest of the data.
Okay. So it's supposed to find your expected results based on the variables and data that you assign to. Another name for machine learning, by the way, before machine learning was called machine learning, do you know what it was called? It was called statistical learning. Statistical learning. In fact, one of the most popular books on machine learning doesn't even have the word machine in it. It's called Elements of Statistical Learning. Why? Do you know why? Do you know why machine learning used to be called statistical learning and why I've put it here in this box? Let me tell you why. Because every single concept in machine learning, every word, you may have heard of classification, regression, fitting, all of these terms, if you find a data science machine learning book, any textbook, or if you look at the table of contents, all of the terms that you will find in machine learning are either directly borrowed from statistics and mathematics or are derived from statistics and mathematics. To put it succinctly, you cannot learn machine learning very well unless you know statistics and mathematics. Now, let me say this, mathematics is a huge field. And you're not expected to know all types of mathematics, but there are certain mathematics that you must be competent in, namely probability theory. Now, statistics is not usually considered mathematics because it has to do, it's about how you collect data, how you visualize data. So it's not a language like math, whereas probability theory is. But statistics and probability theory are very close to each other. So while you can learn, some machine learning, you can write a quick script if you watch a YouTube video or whatever. You won't really understand what that program, you will not understand the meaning of those instructions if you do not understand the terms. So for example, if someone says to you, train the model, and if you do not know what it means to train the model, or if you do not know so there's a function called linear regression. You know how to program it, but you don't know what it means to do regression. And of course, you won't know what you mean because you don't have the statistical mathematics. By the way, you also have workshops on this if you're curious. Now, you've all heard just how incredible machine learning is, right? All of these tech companies, YouTube uses for its recommendation system. Amazon uses it for its recommendation system. So you know how on Amazon, when you're looking at a product, you scroll down just a bit, it says customers who bought this also bought these. So they know your buying patterns. They know what you want to prefer. There was an example where this was a couple of years ago. A machine learning algorithm was able to tell, it was an e-commerce machine learning model. This e-commerce machine learning algorithm was able to tell that a woman was pregnant and she's expecting before her own doctor's note. Basically, when she would go to the website again, they were now suggesting that she buy children's clothes. It's like, why are you suggesting this to me? Well, because the machine learning model had understood that she is looking for looser clothing, and her behavior has changed, right? When women are have a child, their behavior also changes. The model was able to identify that this woman is very likely bearing a child. So they changed the recommendation system. This is one of many, many examples. I mean, machine learning is humongous. You have examples where a machine learning model is able to detect a malignant skin tumor better than one of the most acclaimed dermatologists. They actually had a competition. They showed some of the most renowned dermatologists some pictures of unusual pigments on the skin. The dermatologist said, no, this is benign. But the machine learning model said, oh, this is malignant. And it turned out it was malignant. So machine learning is now used to augment human intelligence. So the point I'm trying to make is this. If we can do all of this with machine learning, and machine learning is statistical learning, why not become statisticians, right? Statistics has been around for a while. It goes all the way back to 17th century. So why don't we tell everyone to learn statistics? Because what they don't tell you, what they don't teach you in statistics and math is how to deal with data, right? What is the number one, when we talk about data, what comes to your mind? Is it like engravings in stone? Paintings in the museum of the Louvre? No, we talk about digital data, JPEGs, PNGs, MPEG-4s, XMLs, PDFs, CSVs, binary. Statistics and math does not teach you how to do that. Or most of mathematics does not teach you to do that. That is the realm of computer science. Working with electronic signals, that's computer programming. And this phenomena we call the internet has created something we call big data. This is data that has 4 characteristics. It is very large. It is being produced at very rapid speed. Like every second, how many people are sending texts, uploading pictures, uploading videos? Number 3, we have a very large variety of data, all kinds of different data. And number 4, veracity. We have a lot of junk data, garbage data, repetitive data, fake news, that comes to mind. So if you want to get a hand of data that is living in the internet, that is Big data, and big data falls under the umbrella of computer programming. So you as a data scientist, if you want to get into machine learning, or if you want to become a data scientist as a professional, you must have competence in this pillar, and the third pillar. This is very important. You know what? This actually even applies to software developers, especially those who are experienced software developers and are looking for jobs. Let me say this in another way. If you want to become a professional software developer, if you want to become a professional data scientist, this third pillar you must have. What is domain knowledge? Domain knowledge means that you must have knowledge about a particular domain, knowledge about a particular industry. Healthcare, banking, retail, finance, manufacturing, television, I don't know, marketing, on and on and on and on. So many of you are probably have a non-tech background, right? I guess everyone in this room has a non-tech, but how about those in the chat? I'm going to assume you don't have a tech background, right? You come from one of the industries that I just mentioned. And you think to yourself, if I learn data science, if I learn coding, what are my prospects? The answer is very high if you do not omit that part. Many people, we have people who join the coding bootcamp or data science bootcamp, and they want to completely reinvent themselves. But they omit the part where they worked in, for example, in the airline industry for 5 years, or they've been working in sales for 10 years. They omit that part. And what I do learn about this, and I tell them, you're doing yourself a big disfavor. If you're someone who has domain knowledge, you are far more valuable than someone who has been in tech their entire life. If you want to become a software developer, you're going to be doing more than just coding. You think people who are software developers come in the morning at 9 a.m. and click on the keyboard all day long and then they leave, they shut down the laptop? No, you have to know how to manage the project. You have to know how to collaborate with people, especially if you want to for one of those big tech companies, Amazon, Google, and Facebook. You need to know how to collaborate. Collaboration is a huge part of software development and data science. So if you're someone who has worked in sales, sales is a very, intense industry. If you're someone who works with retail, you know how to deal with customers. If you work with marketing, if you're someone who has experience with enterprise companies, if you're someone who has negotiating skills, this is a huge asset. So whether you want to become a data scientist or a software developer, there's 3 things you need to have: project management skills, communication and collaboration skills, and technical skills. If you have these 2, if you're someone who's coming from outside tech, you have those first 2. Now you need to acquire the tech. So if you have 50% of the technical experience, but you have a substantial experience in project management, communication, collaboration, you are far more valuable than someone who has exclusively technical experience. They don't know how to collaborate, or they don't know how to manage their projects. And believe me, I've worked in tech all my career. You have a lot of people who are negligent in these 2, and that's problematic. So data scientists, especially those in the chat today, in our workshop today, I'm sure you have this first one. So just be sure you already have an advantage. Now prioritize these 2. And if you're a software developer, prioritize data structures first and foremost, and those programming constructs I showed you previously. Very good. Let me see how much of this I can feed in. Okay, let me make this quick. This is a good comparison between machine learning and programming. Programming is about this. It's about writing rules and those algorithms, right? We said algorithms, set of instructions. Feeding data into those instructions to get the answers that you want. For example, you write an algorithm for registering a user, and the end user starts to give you the data. Now we will take the data, the computer will take the data, because it already has the algorithm, and it will know how to register the user. It will capture the first name, the last name, email, password, contact number, send to the database. It will do all of that because it knows the rules and the data is presented to the algorithm. Machine learning has a different motivation. With machine learning, we want to figure out the rules of the world. We want to know what causes people to register. We want to know what causes the price of something to appreciate or depreciate. We want to know what causes someone to have diabetes or a malignant tumor. We want to know what causes, for example, people to prefer this product over that product, this movie or that movie. So we give the machine learning algorithm our data and the answers we want it to find. We want the machine to know which stock to buy, which company is going to be popular, which biological factor is going to contribute to disease. And we want the machine learning algorithm to go ahead and find out the rules that govern this. What are the rules? What are those things that cause a price to appreciate? What are the things that cause tourists to stop coming to our country? What are the things that cause people to get into more fatal accidents? Right? We have so much data that it is not possible for a statistician to use statistics alone to figure out the patterns in all of this data. For example, with the COVID vaccine, they want to know, for example, how fast the disease will spread. If we use traditional statistics, there's no way we can consume all of this data and make sense of it. We need to introduce some automation. Machine learning, like I said, is also known as statistical learning. So it automates some of those tasks that statisticians do. Okay? Now, of course, there are 3 types of machine learning. By the way, in our bootcamp, we cover the first 2. The third one is a little more advanced, but if you want to get into machine learning, you want to start with supervised learning. Then you want to learn about unsupervised learning. And then once you really, you've learned a great deal about both, you can jump into reinforceable learning. Reinforceable learning, you see, is a lot of probability theory. So if you do not know probability theory very well, reinforceable learning will be hard for you. But very quickly, here's what they're used for. I'll make this very quick. Supervised learning is what you could use it for predicting future values, future value of a price, future value of COVID outbreaks, future value of future number of tourists who would visit Dubai. So you show the machine learning model a pattern, it will learn from the pattern, like you said, and once it has learned the rules of the game, the rules of that phenomena, when it sees data the next time, it will be able to predict it. Okay? Now, there will be cases where you, as the practitioner, do not know the rules yourself. For example, you do not know how many strains of the COVID there are. We recently learned that there are at least 2 new strains of the COVID virus. How many more are there? We won't know. So we will pool in all our data, and we will use statistical learning to find these things we call clusters or different classes. The machine learning model will identify different factors or what distinguishes this data from that data from this data and categorize them for you. And you, as a data scientist, as a healthcare professional, can stand back and say, oh, I see, we have 3 categories of data. There are 3 types of the COVID strain. Here's how they are different. The third one is reinforceable learning. This is used in financial technology. Like I said, there's automated buying and selling of those stocks, or for example, autonomous vehicles. Reinforceable learning facilitates that. Again, I go deeper, further. I've gone deeper in this before in a separate workshop. You should check out our YouTube channel about this. Now, let me talk about cryptocurrency. If it's okay with you, let's also push this workshop for 15 more minutes, just so I can make time for you to ask questions if you have. Cryptocurrency and blockchain. Focus on the second part of the word, blockchain. What does the word blockchain mean to you now? This is a word that is terribly abused. This is a word that is thrown around, like loose change, but still people don't seem to know what it means. So what does the word blockchain mean to you? In 1, 2, 3 words, describe what blockchain means to you. What do you think it means? Chain of blocks. Very good. What else? How about those in the chat? Don't Google this. Do not Google this. I don't want a correct answer. I want to know what you think blockchain means. A lot of data that is connected. That's very good.
And you can't alter the previous.
Yes, that's good. We're getting a clear picture. A chain of blocks, a lot of data that is connected, and they are immutable, meaning they cannot be changed. So let me tell you. Let me first set up the discussion. Why do we have blockchain? Why is it such a big deal? So we have something called, this is a technical term, okay? This is part from a book. I wish I had the reference link below. I forgot to do it for you. But these are technical words. We have something called the blockchain system. In the blockchain system, in order to bring a blockchain system to life, and I'll tell you about the motivation in a second. We need to have a blockchain network. We need to have a blockchain data structure. Now, here's a word you've already seen. This is very important if you want to mix it to blockchain, the meaning of data structure. And the blockchain protocol. What these three words mean, well, let me jump ahead to the subsequent slide. Let's start with this. This is not here by mistake. I'm sure you all recognize what this is. It's a bill book, right? You go to your grocery, your laundry, right? You write down the price by hand. You sign. The laundryman takes a copy. You take the proper copy. But why do we do this? What's the purpose of, writing on this booklet?
Validation.
Exactly. So we both have a copy, a carbon copy of the transaction. We both have proof. So for example, if I had written on that receipt and I had just given you the original copy, you can go back, doctor it, write over it, come back and say, you cheated me. You said 10, but you charged me 100. Look, here's the proof. Now, who's going to verify the claim? Unless we have copy. That's why you have three sheets here. There is three. So if you doctor yours, there's another copy I have, and there's a third copy. We can compare. This is called a ledger. Blockchain, by the way, has nothing to do with a particular programming language or a particular data structure. It's just an idea that generalizes this ledger idea. Why have a copy for me and you? Why not give a copy to everybody? Just go beyond. Why just you and me? Let's everyone copy. If I buy something from you, this transaction that we had, I will have a copy, you will have a copy, she will have a copy, she will have a copy, everybody in our network will have a copy. So if any of us dare doctor that transaction, hundreds, thousands of millions of people who are telling you, no, it's wrong. So you cannot fabricate, you cannot lie, you cannot deceive, because you're not going to be able to change everyone's copy. Let me jump this slide and I'll come back to the one previous. So these are some of the things blockchain can facilitate. Digital rights. This is a big problem. If you're a journalist, if you're a writer, if you're a photographer, right? You take a picture, you work hard for that picture, you put yourself at risk. Someone takes that picture, puts it on their website, not even a credit. You don't make no dime. Or someone makes an exact copy of it. You claim this is my picture. How are you going to prove it? Because even the date, and so you have something called the metadata, which stores the type of camera used. Even that can be changed. So how are you, as a writer, as a journalist, as a storyteller, as a movie maker, as a photographer, going to claim ownership? This. But give everyone a copy. Write down the name of the asset, the original author, the date, give everyone a copy.
But then what stops me from also doing the exact same thing? If I see your picture,
I made it first. I recorded that picture first.
so then who validates this?
Everyone validates it.
So
This is what comes to what we call the peer-to-peer. Now, I'll come to this in a second. I'll answer your question in a second. So digital rights is another one. Escrow is another one. You know what escrow means? Escrow is, for example, let's say you're a freelancer, you do a job, and you expect the company to pay you. Or more generally, this is a big problem with SMEs, right? A company supplies something, but the customer does not pay back. Or the person who bought the product from you does not pay, or they don't pay on time. And escrow is a third party who takes the money from that company and holds on to it. When you complete the transaction, they will release the money to you. That's one thing. So that's smart contracts. If you hear that word smart contracts, here's an example. Also securities, right? People now buy stocks, digital stocks. But now we've gone beyond things like gold and cars and houses and yachts to digital currencies. You may have heard something called NFT, where people buy tweets. You can own that tweet. You can own a video. You can own, for example, a 6-second video. It can become yours. And as time goes on, because it's considered art. But since it's digital, the problem is how can we establish authority? How can we establish ownership? Once again, using this generalized ledger, this peer-to-peer ledger.
This is a small question.
Yes.
Why would anyone buy a tweet?
It's just like buying a painting.
But it's in a public domain. The ownership is of the author of the tweet.
And not only this, they sell it. So now you have this thing where the person, for example, the sports journalist who captured that video, now that video belongs to, for example, a sports channel.
I understand your videos
Right.
and images. Like, you could perceive it as art.
Right.
But in textual tweets.
So it's just like, this is like the Mona Lisa, right? The Mona Lisa, everyone can see the Mona Lisa. But if you own that painting, it's just how it works in the art world, where people value it somehow. Or the fact that other people value it makes you holding that painting valuable, meaning you can resell it. You can sell it for a higher price. If there's a painter, let's say in Dubai, and she dies, she passes away. Suddenly, because this artist is no longer alive to produce more artwork, the value of artwork appreciates. By virtue of being scarce, there's actually a nice quote from a very well-known economist. The very fact that it's scarce, that this artist is no longer around, or this is the one of a kind, makes it valuable. The artist never makes the money, but because it's rare, even it could be the ugliest painting. You've seen those auctions. They sell nonsense, like pieces of cardboard with holes in it, and you think, who would buy this? They do buy it.
There's a whole industry.
Right, because it's scarce, because it's one of a kind, and that person is no longer there to make it, this makes it value. Like gold. Gold doesn't have that much use case. It's just shiny, but people value it because it's scarce. Anyway, I'm just telling you that you could make it. You can own a commodity, a digital commodity, and establish ownership. Digital currency, of course, that's a big one. Bitcoin, Ethereum, blah, 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 blah. It works the same way. It's a big topic. Maybe, I can't get into it now, but the concept applies the same. If I own a Bitcoin or a percentage of a Bitcoin, the way I establish that ownership, that this is my money, is again, because this is in the network. Voting rights, of course, this is a big problem, right? Voter fraud, and I'm sure you've heard of this. Owning products, inheritance, and all that, even that could be established by the blockchain. So let me talk about how this is different. If you own someone a money, or if you need a safe place to hold your money, there's usually a central authority. That could be the bank or the central bank of the government. It could be the civil court, which adjudicates between who's the defendant and the prosecution, right? But you have a central authority. And many people have found flaws in this system where everything is centralized, right? A central bank, for example, can start printing out more money, which causes the value of the currency to inflate, become worthless. And people do not like this. And there are many economies where this currency is mismanaged horribly because they're simply incompetent. When you decentralize it, when it's escrow system or when it's ownership, in some countries you can bribe someone and you can dock the document, and that's you against the legal system. But it's yours, but it was doctored. So when you have a peer-to-peer network, this is what I mean. Everyone has a copy. No one owns the copy. There is no central authority. I have the copy, you have the copy, she has the copy, everyone has the copy. And if anyone attempts to doctor it, which by the way, that's a very huge technical challenge, but if anyone attempts to doctor it, everyone has a copy of it. And no one owns, there's no central authority. So you cannot steal, you cannot lie, you cannot deceive. You cannot control the currency. The people control the currency. If it appreciates, it's not because a central government is holding on the currency. It's because people value it more, because people are joining the network. So that's the idea about blockchain. And by the way, there's a big difference between encrypting and hashing. I'm not sure how much cryptocurrency we can get into right now, but they're different. Encryption is a method, it's a technique where you change the original form of data. For example, you take your name or your email address and you mutate it. You add some numbers and letters here to obfuscate the original value. But you can go the other way around. You can decrypt it. Hashing, however, is a one-way transaction, meaning once you mutate the data, you cannot get it back. However, if you have the original data, every time you hash it, you will get the same encryption. You will get the same hash. Let me put it in another way. Let's say that I own a piece of artwork, and my ID in the network is attached to that artwork. This is his artwork. If I know my ID and I feed it into the hash function, I will get some mumbo jumbo, some string. If you try to feed your ID into a string, you will get a different string. As long as I know my ID, every time I pass my ID to that hash, I'll always get the same result. Not so with encryption. With encryption, every time I pass my own ID, I'll get a different. So why am I talking about hashing? Because I want to come to this business of mining. The only way you can figure out a hash function basically is a mathematical function that, for example, takes a number, multiplies it by something, divides something, adds something. It just changes the number somehow. But every time you pass the same number, you will get the same hash. If you know the formula of the hash function, you can figure out, for example, the way you can mine a currency, a Bitcoin, for example, is if you can solve a hash function. Now, the problem with hash function is you have to do it by brute force. You just have to guess. You have to sit down and say, I'll try this combination. Does it give me the hash? No. Let me try this other combination. Does it give me this hash? No. Let me try this other combination. So you know how these mining computers spend a lot of electricity? That's because they're trying to find which combination they use to produce the hash. That is why they use so much electricity and why they cost so much money.
So, if I were to use your example as well, you have a painting with your name on it, you pass it into a string, and then these miners have the job of finding out your hash key.
No, that's ownership. I'm talking about mining a Bitcoin. So you know that.
What are you trying to decode?
Very good question. So we have a finite number of Bitcoins. We have a finite number of Bitcoins, or we have other cryptocurrencies. We have a finite number. Let's say 1 million. Okay. In order to earn a coin, you must figure out a hash function. You must figure out what mathematical expression produced that hash.
Basically, it's solving a
mathematical expression. If you can figure it out, you can claim ownership of that coin. It's now yours.
So your coin has a hash, and you got to figure out
Precisely. Exactly.
Coin.
Yes.
And so you figure out, I own it.
You own it. Your ID is now associated with that coin.
So who decides how many coins there are? So
Everybody. When you earn something, everyone gets a copy of your. Everyone has the record.
So, when the cryptocurrency starts, a program has decided that there are 1 million coins,
Exactly.
and each coin has these hashes. And now all of you'll figure out.
Exactly.
You'll figure it out.
Exactly.
And then you earn my coin.
Exactly.
Okay. I understand the logic.
Right.
But I don't understand why.
Very good question. And here's that quote from that famous economist, Lionel Robbins. He said, economics is a science which studies human behavior as a relationship between, now watch this part, given ends and scarce means which have alternative uses. I want you to focus on the second part of a sentence. Scarce means which have alternative uses. In other words, like I said, anything that is scarce, anything that cannot be replicated, by the virtue of that has value. Just because you can't have more of it. Gold is finite. Diamonds are finite. The painting an artist produces is finite. The song, the music someone composed is finite. A book a very famous writer wrote, the original copy. There's one of a kind in that world. Because it's scarce, it becomes finite. And because it's finite and everyone wants it, the more people want it, the higher its value. Like baseball cards. You know that there's a huge business with baseball cards. The older the baseball card is, people have passion, they like to collect these things. They may have a large collection, but that one baseball card is missing. And they're determined to have it. Now, to you and I may say, why it's just a card, just get a copy. But no, there is like a subset of people who value owning it. It's like a bragging right. Like a car. You can say you can get a Honda Civic. Why do you have to go get a Lamborghini? It's the same thing. Yeah, but it's a Lamborghini. And there are not as many Lamborghinis out in the world. So because it's scarce, because it's finite, it makes it valuable. That is why Bitcoins are necessarily why they were made to be finite. Why there was a set of, like there was a fixed number for it. If they introduce Bitcoins, which they can't because right now everyone is on the network, that will naturally, just like fiat currency. The problem with fiat currency is now it's not backed by gold anymore. You cannot prove that a $5 bill represents this percentage of gold. Exactly. But as Bitcoin tries to say, no. This is finite. It will remain finite. So if you have a piece of that, 2% of that, 0.002%, you actually have that much of this asset.
So then over time, like it requires a lot more computation resources.
Exactly.
Why is that?
Because some are more.
Why does it get more difficult?
Some have bigger hash. Some have more sophisticated, like more elaborate hash functions than others. They have more expressions than them.
Oh, that's it.
Yes.
So it's not the same scale of hash among the
Exactly.
coins.
So for example, it's very
some easy and some difficult.
It's very easy, for example, to multiply a number by exponentially. Yeah. It's very hard to divide it back. Yeah. To find what is it that caused that number to be multiplied by exponentially. So if you keep multiplying by a bigger exponential number, it becomes harder to find the divisor.
All of this is just one big mathematical game.
Yes, it's one big mathematical game. Now, there are some cryptocurrencies who want you to solve mathematical problems for the sake of figuring mathematical problems. Like, it's not just to make you rich, but to actually solve a problem. So say, hey, solve a problem for us in the real world, then we can make some money while you're at it.
Yeah, that makes more sense.
That makes more sense. So Bitcoin is one of them, and there are other cryptocurrencies. I'm not an expert, but fundamentally, this is how I know this is how it works. Very good. Now we've gone over time, but I still hope you found this valuable. Let me take 5 or 10 minutes for questions about the things we've covered today. In particular, if you want to go forward, if you have any questions, do you have any? How about those in the chat? Now, let me jump in here. If you want to get into coding in particular, the 2 programming languages that I suggest are Python and JavaScript. Why? For 3 reasons. Reason number 1, these 2 programming languages are especially easy to learn. Remember those programming constructs I told you about? For example, with Java, C++, Kotlin, and others, you cannot get started unless you know the most advanced programming construct. You have to. Whereas with JavaScript or Python, you can fire up your browser with JavaScript. Or in Python, you write 1 line of code and you can really get started with very simple stuff. And you can work your way to the most advanced programming constructs. Number 2, because they're simple, they have a huge community. And huge community means what? Plenty of tutorials, plenty of documentation, plenty of examples for you to learn from. And number 3, they are especially general purpose. Python and JavaScript have a very broad range of applications. In fact, more than the others. So it's easy for you to learn. It will be quick for you to learn. And there are many things you can do with these 2 programming languages. Okay? So keep that in mind. Now, I want to thank you also for staying with me. You have a question? Yes, let me know. Yes.
I apologize for asking.
No, not at all.
All right, so like in your opinion, what's the main drawback of JavaScript? Why is it not just universal?
It has become increasingly universal.
But there are some caveats.
The drawbacks are that JavaScript is a programming language that was created in only 2 weeks. So there are some advanced constructs that JavaScript doesn't have. So that is a drawback. It is also
multi-threading is a big problem.
Multi-threading. Now, there are libraries, but primarily it has to do with that it is loosely typed. If you know what a type is, JavaScript does not enforce it. So there is a workaround called TypeScript. And it's called TypeScript because it's JavaScript, but it's strongly typed. So you program in TypeScript like you would C++, but it converts to JavaScript. But you don't have to worry about it converting to JavaScript. You can focus on doing your strongly typed programming language. So really, JavaScript is increasingly taking over even the space of Python. So right now, when it comes to data science, Python is king. But JavaScript is increasingly pushing its way even in that domain. So it's a general purpose language in a true sense of the word. We even have robots that are programmed with JavaScript because of these 3 factors: simplicity, community, and the fact that it's general purpose. Definitely worth an investment. Any more questions? One more? Yes.
Are you invested personally in Bitcoin?
It's a good question. I am not invested in cryptocurrency. I'm considering it, but even this is new to me. So that's all I will say about that.
I am since 8 years.
16 years? Wow.
Wow. Take his number. He's rich.
Who also has been long
No,
time
I actually bought Bitcoin and Dogecoin stuff just as a joke when I was a student.
If I can interrupt.
But it didn't reach.
We do have a Bitcoin investor from 8 years, so we'll try to get his number for you. Maybe he can give us some investment advice. But thank you all for being with me today. I look forward to having you in our next session. But for now, enjoy your evening, and bye-bye.